So welcome everybody to the 6th webinar of the VALITEST series on organization of test performance studies. So VALITEST is an EU-funded project undertaken by a consortium of 16 partners and built to improve the reliability of diagnostic tests performed in plant health laboratories across the region. So you can find more information on the project on our website. So we are in the series on test performance studies. So test performance studies are interlaboratory comparisons that aims at evaluating the performance of diagnostic tests. And during this series, VALITEST partners are presenting the different steps of the TPS workflow through videos, webinars, and training activities. So during today's webinar, we will discuss about how to tackle the analysis of TPS results. So the presentation will be recorded and a link to the recording and the PDF of the presentation will be provided on the VALITEST website. Also note that a video will be launched from the platform during the webinar, and if your connection is not stable or if you're joining using the web app, the video can stop in the middle and not restart. So if you have this problem, please try to leave the webinar and come back or watch the video on YouTube. I will provide a link. Also, please do not hesitate to write in the chat in case you have a problem, and do not hesitate to ask questions also in the chat during the webinar. So today, our speaker is Jenny Tomlinson from FERA. So Jenny is a molecular biologist with 15 years experience in the design, development, and deployment of molecular diagnostic technologies. She has been involved in many projects in support of EU and UK DEFRA plant health policy, including the VALITEST project. And there will be a Q&A session at the end, and we will be joined by two TPS organizers. So Monica Mezzalama, who works at the University of Torino in Italy and organized the TPS on Cryphonectria parasitica, and Marta Luigi, who works for CREA in Italy and organized the TPS on TOB-ORV. So with no further ado, I will give the floor to Jenny for this webinar on how to tackle the analysis of TPS results. Have a nice webinar.
Thanks very much for the introduction, Charlotte. So yes, welcome to our webinar about how to tackle the analysis of TPS results. This is the outline of the presentation. Towards the end, then we're going to see some videos, as Charlotte mentioned, interviews with TPS organisers from the VALITEST project, and then there'll be time at the end for questions and answers. So this is the latest in a series of webinars from the VALITEST project, covering each of the stages of the organisation of a test performance study. This webinar is covering aspects of collecting results and analysing data, but there are actually some other training events which cover a similar area. So we'd also like to direct you to some videos which will be available on the VALITEST website starting from today on the statistical analysis of data, and that will end with a Q&A session a week today. And also there's some practical training next week as well on the same subject. So we'll start with a quick question to the audience, just so that we know who's in the audience and how much experience you've had. So a very simple question: have you already performed an analysis of TPS results? And we'd just like you to answer yes or no.
So we have about 80% of the people that have answered. I will wait a bit longer. So we are around 90%. So I will close and share the results. So yes, we have about 23% of the people that have answered yes and 77% that have answered no.
Okay. Okay, so about almost a quarter of the people watching have analysed TPS results. So 23% of the people watching will already know that analysing the results can be one of the most challenging aspects of organising a test performance study. So when we're talking about analysing the results, we are talking about the statistical analysis, and as I said, that will be covered more in other training events. Actually calculating statistical performance characteristics of the tests involved in the TPS. So analytical sensitivity, repeatability and reproducibility, diagnostic sensitivity and specificity, and then other measures derived from those, such as likelihood ratios. But before we can get to that, first of all, we need to extract the data from the results sheets that the TPS participants have submitted. And we need to consider whether those results are suitable for inclusion in the analysis. So that's what I'm going to talk about. And once again, we direct you to the videos which will be available on the VALITEST website for the detail about the actual statistical analysis. So if you're the TPS organiser, then you receive data back from all your participants in the form of results sheets, which might look something like this. So these are examples of the results forms which we used for our TPS for Fusarium circinatum. So conceptually, the results forms should be very straightforward, just a list of the test results for the samples that we sent out for each of the tests. But there's also a lot of other information which we need to capture, and the format of the result sheets allows the participants to include the other information that we need, as well as just a list of positives and negatives for each test. In fact, the data is likely to be much more complex than just a list of positives and negatives. If you have a panel of samples, which is of at least the minimum size recommended, and you have at least 10 participants, which is the minimum number of participants recommended in a TPS, then we're going to have over 200 data points for each test. And they will have been randomized. So when we send the samples out to the participants, we randomize them, anonymize them, and then when the results come back in, we obviously need to untangle the randomization that we previously imposed on the samples. The format of the result sheet should be planned with that in mind. So an Excel spreadsheet is going to be much more useful than a text file, for example, and ideally it would be formatted in such a way that we can extract the data efficiently from each of the results sheets. But as I said before, there's also additional information which we would ask for in a results sheet. So for example, most of the tests will be qualitative, and we just want to know, did you call this sample as positive? Did you call this sample as negative? But there's other information, raw data, such as measurements, amplification plots, gel pictures, which the TPS organiser might ask the participants to send so that they can scrutinise the results in more detail. So once we've got the results back from the participants and we've extracted it from the individual results sheets, and we've untangled all the randomisation and we have the data in front of us, we need to ensure that the data is actually suitable for analysis. So we're just going to ask another quick question to the audience. So it's a slightly leading question perhaps, but the question is, do you think that it's important to exclude results from the analysis? So do you think, yes, only valid results should be included in the analysis? Do you think, no, the results are what they are and every result should be taken into account in the analysis? Or do you think it depends on the context? So we'd like you to answer this question. Choose one answer, please.
So people are still answering, so I will wait a bit longer. We have 85% of the people that have voted. Okay, so it's not changing anymore. We are almost at 90%, so I will close the poll and share the results. So we have about 34% of the people that answered yes, 13% that answered no, and 53% that answered sometimes. It depends on the context.
Okay. So
Sorry, I cannot hide. Yeah.
okay.
Okay.
So so that's good, because we're going to spend the next 20 minutes talking about excluding data and choosing to exclude data for results. So it's good that most of you think that it's sometimes a useful thing to do. First of all, let's start by thinking about inconclusive results. So some tests, perhaps a minority, but some tests that might be included in a test performance study have only two possible outcomes, positive or negative. So for example, if you think of a lateral flow device that's being read by eye rather than a reader, either you can see a line or you can't. The test is either positive or negative. But for perhaps the majority of tests, a third result is possible, and we can call that inconclusive. So where we've failed to call the sample as definitively positive, and we failed to call it definitively negative. So a lot of the tests which we're treating qualitatively in a plant health context actually generate quantitative data. So for example, in real-time PCR, then we're trying to call the samples as either positive or negative, but we're actually recording CT values. And for tests where there is qualitative, where the result is qualitative, but the data generated is quantitative, then we can define a sort of grey area in the test. For example, having a cutoff value in a real-time PCR. So we're not talking about a cutoff value where, for example, you run the real-time PCR for 40 cycles, but anything over 36 cycles is called negative, because that's just the definition of a negative result. What we're talking about is a cutoff where if the CT value is between 36 and 40, then we're saying it's not positive and it's not negative, it's inconclusive. Now, CT cutoffs in real-time PCR are not straightforward. So not all real-time PCR assays need a cutoff, and the ones that do, you have to bear in mind that the actual value of the cutoff can vary depending on equipment and other factors. And for real-time PCR assays in EPO diagnostic protocols, then where there is a cutoff value used, then there's a note to say the actual value of the cutoff has to be verified by each lab implementing the test. So it's not necessarily straightforward to determine where that cutoff should be. If there is a cutoff in the method, or if a participant has chosen to impose a cutoff on their results, then it's probably important to look at the raw data as well to try and understand how they're interpreting results which fall in the grey area above the cutoff. But that's an example of a result which is not being called either way. It's not positive or negative. It's defined as inconclusive. Another example might be if the test involves running reactions in replicate. So for example, if you have to run duplicate reactions and you get one positive and one negative, the test might say, in that situation, call the sample positive. It might say call the sample negative, or it might say if you get one positive replicate and one negative replicate, don't call it either way and call it inconclusive. So in real life testing in the lab, then if you got an inconclusive result, so a result which you couldn't reliably interpret either way, then you would probably repeat the test. And the TPS organizer might instruct participants to do that. So if you get any inconclusive or uninterpretable results, just repeat the test for that sample. Obviously, the amount of sample is limited in a TPS, the amount of reagents might be limited, the amount of time that you have to do the testing is almost certainly limited. So it might be possible to do a certain amount of repeated testing, but not indefinitely. You can't repeat over and over and over until you get a conclusive result. And so if it's still not possible to obtain a conclusive result one way or the other, then we can treat this result which stays inconclusive in the same way as a missing result. So you might have a missing result, for example, if you lost the sample or dropped a sample in the bin before you could test it. So in that case, you have the absence of a result rather than a false result. So we can think that an inconclusive result can be treated as no result and excluded from the analysis. Obviously, the tendency of a test to generate uninterpretable results is an important observation, and it's not the same as results missing due to a dropped sample or a lost sample. It actually is a feature of the test, the tendency to generate results which can't be clearly interpreted by the end user. And also, in the event of a missing result or an inconclusive result, the TPS organizer might decide to just ignore that result, so just exclude that result from the analysis. But certain results, if they're missing, make it impossible to tell whether the whole data set is valid, so the entire set of data for that test from that lab. And in that case, the TPS organizer might need to omit the whole data set rather than just the individual result. So that's how we might consider inconclusive results. Obviously, a result which is inconclusive is not concordant with a positive result, but similarly, it's not a false result. So if it was a genuine diagnostic situation, it wouldn't be leading to the wrong decision being made. So it's more analogous to a missing result rather than a false positive or a false negative. And for that reason, we can generally exclude those from the analysis. So let's talk a bit more about exclusion of results from the analysis. We need to make sure that the data is suitable for analysis, which is to say we're looking to identify outliers. And there are statistical approaches to identifying outliers after the analysis. So we can perform the analysis and identify outliers and then determine whether we should exclude those. But there are technical reasons for data points to be outliers. And if we can look at those reasons, then we might choose to exclude data from the analysis from the beginning. But this depends very much on the expertise and the judgment of the TPS organizer. So the two main reasons why you might exclude data from the analysis are based on the results obtained for the controls, which have been run alongside the samples in the same data set, and also because of deviations from the protocol. So we'll talk about controls first. So obviously, we're generally running positive controls and negative controls. So the positive controls might be isolation controls, so infected material that's infected with the target pest that we're interested in, or it might be an amplification control. But either way, a positive control, obviously we expect it to be positive, and it allows the interpretation of negative results. So if your positive control is negative, that means any negatives that you see amongst your samples might also be false negatives. So the positive control allows us to interpret negative results. And failure of your positive control might indicate that the test has failed. If it was an isolation control, your extraction might have failed, the amplification might have failed, perhaps it was a mistake, perhaps it was a problem with the samples or the reagents. We also obviously run negative controls. So that again might be an isolation control, or it might be an amplification control. We expect it to be negative, and it's the purpose of the negative controls is to allow interpretation of positive results. So if your negative control gives a positive result, that means any other positive results amongst your samples could also be false positive results. And again, it could be caused by error. Failed negative controls quite often indicate contamination at some point in the process. So that could have been contamination during extraction, it could be aerosol contamination whilst preparing the test. So it could be sporadic, or it could be across all samples, or it could have just been an error. So as I said earlier, we have for each test, each lab will submit a data set which consists of the results for all the controls which were required and all the samples which were provided. And the TPS organizer might choose to just exclude any data set where any of the controls are incorrect. So it's a prerequisite for inclusion in the analysis is that all the controls should be correct for that data set to be included. So if any of the controls gave the wrong result, an inconclusive result, or if the control was omitted from the testing for any reason. And if you think about it, then what we're saying is that a failed control means that we couldn't interpret the results. So in that case, all the results for all the samples in that data set are inconclusive, as we just said, and in that case, we can choose to exclude them from the analysis. Now, sort of strictly speaking, then you might say that the positive control is only there to allow you to interpret the negative results. So your positive test results don't really need a positive control for you to interpret them, and vice versa. But so technically, if only one of the positive controls has failed, you could still interpret the positive results in your data set, and vice versa. I think generally most test performance study organisers would just would want to see all the controls correct for the data set to be considered valid. So if any of the controls are wrong, then we'll exclude the whole data set. But that's a decision for the TPS organiser to make. It's obviously useful to compare how many valid data sets are obtained for each test. And the decision to exclude data might be perfectly straightforward, or might need a bit more sort of nuanced interpretation. So if we're trying to decide whether to include or exclude data on the basis of controls, there might be sort of sporadic failure of controls, which might indicate a small amount of contamination, or might indicate just sporadic errors here and there. But failure of controls for one test in lots of labs might indicate that that test is particularly sensitive to variables which we're not normally controlling. So we try and control things which are going to cause that test to fail in some labs and not others, but there might be variables which we're not controlling. That's just another way of saying that that test lacks reproducibility. It's sensitive to things which we're not controlling. So when we try to reproduce the test in another lab, then it sometimes fails. Obviously, we don't want to ignore results which demonstrate a lack of reproducibility. We want to know how reproducible the test is. So we don't want to just exclude the results which demonstrate a lack of reproducibility. If we only look at the data sets where all the results are concordant, then we might miss the lack of reproducibility. So this is just to say that as well as drawing conclusions on the performance of tests on the basis of the statistically derived performance characteristics, we might also want to draw conclusions based on the exclusion of data, as well as just the data which we've determined as being valid for analysis. And this variation of performance in the controls might be exacerbated by varying levels of expertise in different labs. So if less experienced labs are more likely to see poorer performance of the test, which leads to failure of the controls. Then their data is more likely to be excluded from the analysis. And this might be exactly what we want. So we might mostly want to look at the performance data for the test carried out in a very experienced lab. That might be exactly what we want to know. This is a test performance study, not a proficiency test. We want to know about the test, not the labs. But we might reasonably also want to know about how the test performs in a range of labs with a reasonable level of relevant experience. If we just know how the test performs in the most specialised, experienced labs with the most expertise, then the results that we derive from that aren't as valid to as wide a range of potential users. So we might want to allow we might want the varying levels of expertise across participants to stay visible in the results, rather than to just exclude the less experienced labs' results on the basis of failed controls. So this might be particularly relevant for on-site methods. In the lab, we do have a reasonable expectation that all the labs carrying out the testing in the TPS have a high level of technical proficiency. But if we're talking about tests which ultimately might be used outside the lab, then we might have different expectations of the test. And just knowing that a test which will ultimately be an on-site test, just knowing that that test carried out in the laboratory performs a certain way might not be the most useful information to have, or might not be the only useful information that we can have. So for one thing, for on-site tests, we might want to take this into consideration when we're planning the TPS, selecting the participants, or we might want to take it into consideration when we're analysing the results and drawing conclusions from the analysis. Because if we exclude less experienced participants' results on the basis of failed controls, then we won't be able to interrogate how the test has performed in the hands of a range of different participants. Obviously, the end users for a particular test is very context dependent, so it depends on who's using the test and what they're using it for. So it might be important to add caveats to the performance data which we obtain in the lab, to say that if the end users are very differently experienced from the specialist operators that you'd expect in a lab, then we probably need to do more work to understand the performance in the specific scenarios that we're talking about, and we don't just want to look at the performance measures which we've derived from the TPS, which was carried out in the lab. Okay, and then just a final some final points about if you were organising a TPS and you were staring at the results that you've had returned back from your participants. Should we include or exclude results, and what difference does that make to the conclusions we might draw? So if you imagine a test which has extremely high analytical sensitivity, but also is extremely operationally complex. So you can probably imagine an example, perhaps a real-time PCR that's extremely sensitive, but very complicated because perhaps the matrix or the pathogen or the combination of the two means that you have to do a very complicated multi-step extraction process. So such a test that's highly sensitive but highly complex might be more susceptible to failed negative controls caused by contamination. So failed negative isolation controls caused by contamination. And that might vary a bit from lab to lab and be associated with labs which have less experience or which use particular equipment for the extraction. If the TPS organizer decides to exclude data from all the labs with failed negative controls, which is a perfectly reasonable thing to do, you have to bear in mind that that will also exclude the false positive results within those data sets. And that means that the estimated reproducibility for that test will be higher than if you'd included those false positive results. And not just reproducibility, but also measures including specificity and positive likelihood ratio and so on. So by excluding those data sets, we're missing the false positive results, and that means we're getting an inflated estimate of the reproducibility. But that a test has low reproducibility because it's very susceptible to contamination. That's a really important observation to make about that test. So where decisions that you've made about the exclusion of data influence the performance characteristics that you're deriving in the statistical analysis, the important thing is to document that conclusion in the TPS report. So the outcome of the statistical analysis might be this is a reproducible test, but you also need to draw attention to the fact that there was contamination probably caused by the complexity of the extraction method, and that that actually makes the method difficult to reproduce from lab to lab. Okay, so there's some points about excluding data on the basis of the performance of controls included in the TPS. So next I'm going to talk about when you might need to or choose to exclude data from the analysis because of deviations from the protocol. So how likely your participants are to deviate from the protocols is affected by decisions that you've made as the TPS organizer early on in the TPS planning process. So we're going to ask a couple more questions to the audience now. So first of all, we'd like you to imagine that you're organising a TPS. On the whole, would you prefer to provide all the required reagents? So you're the organiser. Do you want to send everything to the participants? Or would you prefer to just send the specific reagents? So for example, if it's a PCR, just send the primers. If it's an ELISA, just send the antibodies. So that's the first question about reagents. Do you want to send everything or just a few things? And then the second part of the question is, as the organiser, do you prefer to provide completely prescriptive instructions that tell the participants every detail of what they need to do? Or do you prefer to provide an element of flexibility of your instructions so that individual labs can make their own decisions? So for this question, if you could choose one out of the top two options, so out of the reagent options, and then if you could choose one out of the bottom two options about the instructions, that would be great.
So we have about 75% of the people that have voted. I will wait a few more seconds. Okay, so we are around 80% and it's not changing so much. So I will close the poll and share the results. So I will let you comment, Jenny.
Okay.
If you can see the results,
yeah. So we have just over half of people prefer to just send the specific components, so the primers, but not the polymerase in the case of the PCR. About a third of people are more controlling and want to send everything to the participants, and about 50-50 between how flexibly they want to provide instructions. I think there's like a reasonable proportion who haven't gone for either of the options for both of those, which just goes to emphasize that these aren't trivial decisions to be made, and we'll come on to that in a few slides time. So the next question just is from the other perspective. So if you're the participant in a TPS, do you prefer to receive absolutely everything that you need in the box? Or do you prefer to receive just the things which are specific to that test, and you'd rather provide your own polymerase for the PCR, your own buffers for the ELISA, etc.? So the same as before, if you could choose one out of the top two options, all the required reagents or just the specific reagents. And then as the participant in the TPS, do you prefer to receive extremely prescriptive instructions giving you every detail, or do you prefer to have some flexibility?
So we have about 70% of the people. We are almost to 85%. It's not changing so much, so I will close the poll and share the results. And Jenny, you can comment if you want.
Okay, so similar results to the same question from the other perspective. Interestingly, people, a small majority of people would prefer to just receive the specific components. So just the primers and so on. And there's a bit of a preference for having some flexibility rather than completely prescriptive instructions. Okay, excellent. Okay. So you saw some tests, particularly kits and tests which are more simple to do, like lateral flow devices, offer very little chance to deviate from the protocol. The kit contains everything, and the instructions are what they are. But for other tests, it's very dependent on the TPS organizer to decide how prescriptive they want to be. And there's a continuum between everything being provided, all the variables being controlled, and you just have to go through the motions, and the participant choosing their own reagents and that kind of thing. So obviously the test is still determined by the TPS organizer, because it's not a proficiency test, it's a test performance study. But there are lots of other choices which the TPS organizer can leave open to the participants if they choose. So in the case of reagents, the organizer might choose to supply some or all of them for some or all the tests in the TPS. If the TPS organizer chooses to provide them, then there is reduced chance of deviation, but it costs more for the TPS organizer to do that. The logistics might be more complicated if you're sending lots of different components as well as the panel of samples and so on. And there's potentially more risk of things degrading during shipping if they have to be brought in by the TPS organizer and then shipped back out to all the participants rather than them receiving them directly because they've ordered them themselves. If the participants are required to provide their own reagents, then it obviously costs more to the participants, and that might stop labs from participating. But we need at least 10 labs. For the subsequent analysis, we want at least 10 labs to have taken part. So if the cost to the participants is so high that the labs choose not to take part, then that could be a problem. And also, if we have labs participating in lots of different countries, some of them might have difficulties obtaining certain reagents, and that might cause delays to the TPS timescales. So you might need to take account for that when you're planning the timeline for the TPS. So in the same way that it's the TPS organizer's decision as to what reagents to send and which ones to not send, it's also up to the TPS organizer as to how prescriptive you're going to be in the instructions. So you might want to specify details like you have to use a specific instrument, or you might want to be even more specific and say you have to use this model of this instrument. You might want to say you have to use reagents from this list, regardless of whether you're supplying them or not. You might want to specify them. You might want to specify certain homogenization methods or certain DNA extraction methods. The TPS organizer might choose to carry out initial testing, so to determine which deviations might cause a problem and which ones might be acceptable. So as well as doing preliminary testing to choose the sample panels and that kind of thing, the TPS organizer might also want to do testing to find out what range of reagents could be used without an adverse effect on the test performance, because then they can give the participants options. And the organizer might just need to make some pragmatic decisions. It's a more sort of pure investigation of the performance of the test if as many variables as possible are controlled. But if we control every detail, we might just have too few people wanting to participate in the TPS. So if we're very prescriptive, some labs might not be able to participate if they don't have the specified model of instrument that we're asking them to use. Some labs might choose to not participate because you might be specifying a reagent which they know they don't want to use in their routine testing. But there is less chance that the results will deviate from expectations. So there's pros and cons. If you issue less prescriptive instructions, then you'll get a more realistic picture of how the test performs across a range of labs, but there's more chance that the results will deviate. So if we think of some specific examples for real-time PCR, just as an example technology, there's lots of different reagent options for real-time PCR. You can choose core reagents where all the components are separate. You can choose master mixes where they're already combined in a commercial mix. The availability of those different options might be different in different countries and from different suppliers. So probably what you want to do as the organizer is make recommendations on the basis of your preliminary testing. If you can give more than one option, then that's beneficial to the participants. So instead of saying you must use polymerase X, you can say polymerase X, Y, and Z all gave good results. You need to define what the most important variables are and control those. So for example, a key variable in real-time PCR is the magnesium concentration. So you want to say, we've tried it with X, Y, and Z polymerases, they all worked, but if you can't use one of those, make sure the magnesium concentration is the value that it needs to be. Another example in real-time PCR might be the use of a passive reference. So you might want to tell your participants, if you choose to use a polymerase which is mostly intended for conventional PCR, make sure you add in a passive reference to use it for real-time PCR. You probably want to make sure that whatever the participants choose to use is compatible with the instrument that they have, and so on. And another important thing is to make sure that you tell the participants that they should record any deviations. So in your TPS documents, make sure they're prompted to record that information so that then when you're assessing the results, you can see who's stuck to the protocols as specified and who has deviated and in which ways. So when we're looking at the results, if we think that a data set has been adversely affected by a deviation from the protocol, then we should probably exclude them. If the deviation was inadvertent, then it can be quite hard to spot. So if someone's done something on purpose, then they're more likely to record it on the sheet. Oh, we couldn't get polymerase X, Y, and Z, so we decided to use a different one. If they've changed something inadvertently, like they didn't realise the magnesium concentration was different, it might be harder to spot. Once we've got those results, then we might be excluding results from the analysis, but we're still gaining useful information. So the fact that people have participants have deviated from the protocol and invalidated their results is still useful, because then we can redefine the protocol to say to future users of the test, don't use this polymerase, it won't work. Even if we have results back from the participants and they've made some deviations and none of them have adversely affected the results, that's still useful information too, that we can redefine the protocol by saying all these polymerases worked. So not just the 3 that we'd already tested, but there's a huge long list of polymerases which worked. So looking at what deviations the participants have made from the protocol and whether they adversely affected the results or not generates useful information, which can be commented on in the test performance report. Okay, so that's all that I was going to say for now about exclusion of data on the basis of controls and on the basis of deviations from the protocols. So next we're going to watch some interviews with TPS organisers from the VALITEST project. So they were asked questions about the difficulties that they encountered in their analysis, how they overcame those difficulties, and how specific activities within VALITEST helped with their analysis.
Okay, the first challenge in any TPS or proficiency test or any big study is the data collecting stage. We wanted to collect data in a way that would allow then easier analysis. So we prepared data collection forms. We tried to be not too restrictive on the participants, so it was not completely locked, it was not all in drop-down menus, but nevertheless it was structured. We did define for certain tests how to report on results, for example, as negative, positive, or inconclusive. We did allow participants to provide additional comments, which is always disruptive for subsequent analysis because you have to take special care of those comments. But on the other hand, they did provide us with information what the participants were missing in the forms, and we were able to improve them for subsequent test performance studies. Oh, yeah, maybe I can say that in our case, having organized 2 test performance studies, we were dealing with 230 data sets, which means approximately more than 5,000 individual results that we need to analyze and process in maybe 2 months of calendar time, with much fewer days, and therefore we realized very early on that we need to automate the data extraction from the collection forms that were sent to us, and also the analysis part as much as possible. So we put a lot of effort into that, and we are looking forward to testing this in the future TPS to see how transferable this approach is from these TPS to the new ones.
The identification of outliers was difficult without specific rules to do so. The decision to delete datasets considered as outliers was difficult to make. The identification of outliers was carried out internally, and it was decided to delete all datasets considered as outliers.
One of the problems we had is with the randomization of the samples that we did. It was a bit, could have been done better, so it was a bit of a struggle to disentangle everything and just bring it back to in the right order, but we solved that in the end. But the main problem was for the actual data points that we received, data sets that we received from the participants, is that some of them were incomplete or were not performed exactly as we wanted them to perform it according to the instructions that we sent to the participants. So what we did in that case, if not all controls were reported, or they were not congruent with the expected outcome, these data sets were not used in the final analysis for this TPS.
When we started analyzing the results from each participant, we observed that quite enough of them didn't follow strictly the suggested protocols, but they used different master mixes for amplification and kits for RNA extraction. So we have to evaluate if and how those deviations affected the performance of the test. To do that, we compare the positive isolation control and the positive amplification control CQs for the labs that follow the protocol to those which deviated. Then we establish criteria to decide which data set should be considered valid and which not. We used to do that IPO guideline, reports of the round 1 TPS, and some publication that help us to define the requisite of a valid dataset. Another aspect that should be defined taken into account is the use or not of a cutoff value in the analysis of the real-time RT-PCR data, since this can influence the performance of a method. Trying to raise an advice among the participants' laboratory could contribute to the better evaluation of the tests submitted to TPS.
On a few occasions, we had to go back to the raw data provided by participants to try to explain inconsistent results. This allows us to correct reporting mistakes in the final results file with the agreement of the participant.
I think the biggest difficulty we had was deciding which results to exclude, because some labs didn't follow the technical sheet, and some didn't repeat testing if the controls failed. So we did have to exclude some data because they didn't have controls that worked for their testing. It just led to excluding more data than we would have liked to have.
Work package 2 guided us which methods to use to analyse the data and performed the data analysis independently from us, which allowed comparison and led to detailed discussions around which data to exclude from the analysis. Work package 2 also, they shared R code for calculating concordance and accordance, which allowed us to check the differences in results, which were based on initial differences in data exclusion only, not methodology differences.
For me, especially the discussions with other organizers of the TPS helped me to get a better and sometimes different view on selection criteria that can be applied to include and exclude data sets. And that was for me the main point that helped me a lot.
The presentation made by the leaders of the specific VALITEST work packages during summer 2020 and the reports describing all the criteria that should be evaluated help us to focus the topic and understanding the best way to proceed. Some more detailed information was asked later, receiving prompt answer during the final stage of analysis for the presentation of the results.
So Jenny, we are running a bit late, so if you can quickly conclude.
Yeah. Okay, so just very quickly summarising the TPS organisers' experiences. It's a challenging stage of the TPS organisation Automating the extraction and analysis of data can increase efficiency. It's not straightforward to identify outliers and decide whether or not to exclude data, but additional information from the participants can help to inform these decisions. And outputs from activities within VALITEST have helped the organisers in their data handling and analysis. I'm just going to very quickly comment on what we want to do with the data once we've done the analysis. How do we actually want to use the results? The main reason is obviously to inform the choice of tests. So which is the best test for my application, although there's lots of other factors to take into consideration. There might be shortcomings across all the tests in the TPS, and that could inform development of new tests. For example, if all the tests in the TPS cross-react with a particular non-target, then that could inform development of new tests. It helps you to understand uncertainty associated with results of a test that you're using, and potentially also how you might use multiple tests in combination to achieve a particular outcome. And then just finally, to summarise, the ability to determine whether your data sets are valid and the ease of handling that data often relies on decisions that, as a TPS organiser, you've made earlier on in the TPS planning process. So the scope and the selection of participants might influence how you treat outliers. Your choice of controls to include in the panels will affect inclusion and exclusion of data. Your instruction sheets and technical sheets will determine how likely participants are to deviate and whether that's good or not. And how you design your results forms gives you opportunity to capture additional information, which you should take, but also how you design those forms might allow you to handle the data more efficiently and even automate the extraction of the data. And if we carefully consider the validity of the participants' data, that means that the conclusions that we can make on the basis of the statistical analysis will be robust. Thank you for your attention. If anyone has any questions, that would be great.
So thank you, Jenny, for the nice presentation. Marta Luigi will join us, but unfortunately, Monica has to leave. I do not have questions yet in the question panel. So if you have questions, please do not hesitate to ask them. You can either use the chat or raise your hand, and we will give you the floor. Okay, so we have a question from Amandine Levan. So I will unmute you, Amandine.
Hello, I have a question about the deviation from a protocol. Do you or can we use that for assessing the robustness of the method of the protocol?
Yes, I think so. I don't know whether it's something that you could sort of design into your TPS, or whether it's just something that you could do sort of opportunistically afterwards. So if you can see that participants have deviated, then you could draw some conclusions about the robustness, and that would be in addition to the statistical determination of reproducibility indicated by concordance, which is what the statistical analysis would be telling you. So yes, I think you could.
I don't know, Marta, if you want to add something on that question.
In our TPS, we had most of half of participants that made deviation from the proposed protocol. So we assessed robustness of the protocol we proposed, comparing the accuracy from the participants who makes deviation versus participants who didn't make any deviation. And we don't have any statistical differences between those values. So we assessed that the robustness of the protocols were good.
So we have a question in the chat from Lina. So during TPS, the participants know the positive, negative controls included in the panel sample, or are those blind tests?
I don't know whether Martha could answer that question. So I think in ours, then yes, all the samples in the panel, including the controls, are blind.
No, the controls were named, but the rest of the samples were blind. So everyone knows the positive and negative controls, and the rest were named from starting from 1 to the end of the panel.
So for now, there is no other question. Yeah, I have Amandine who raised her hand again. So Amandine, you can go ahead. Yeah.
Yes, I wanted to know if you have already asked a participant to redo an analysis or to redo a test. For example, if he make an error but he didn't notice it, or you see it after, for example, with his internal control or something like this. So is it possible to ask to do again the analysis after the end of the study? When you do, after you have done your, or when you begin to do the analysis? Is it clear? Or?
I think it would be possible to do that. It might be preferable to not do that because of just the timescales. So if the particular, well, within VALITEST, then the timescales are quite short for the test performance studies, so there wouldn't have been time, I don't think, to receive all the results back, do an analysis, even a preliminary analysis of the data, and then go back to individual labs and ask them to repeat testing. So we included instructions initially to say, if you have an inconclusive test, if anything's contradictory, if anything's unclear, then repeat the test. But that was in the instructions. Once the results were back, then there were, yeah, we didn't go back and ask for any further analysis to be done.
Okay, thank you.
So we have no more questions so far. So I would like to thank Jenny for the nice presentation, and Marta and Monica for joining the Q&A session. Also, Monica has to leave because we're a bit late. Thank you to all the attendees for participating to this webinar. There will be a satisfactory survey at the end of the webinar or in the follow-up email. It is really short, so if you can provide feedback on the webinar, it's always welcome. And the presentation and the link to the recording will be available on the website. We will have the next webinar, so it will be a question and answer question next Monday. So during this week, we will release videos on how to calculate performance characteristics of a test and how to get useful information from your validation data by statistical analysis. And we so strongly encourage you to watch these videos. And then if you have any question, there will be a session, so next Monday, just to answer the questions. And there will also be a practical training session next week on how to analyze the results of test performance studies. The registration are closed, but if in case you really want to join, send us an email and we will see how we can fit you in. So thank you so much, and see you next time. So next Monday for the next webinar. Bye-bye.
Thank you.
Bye.